Hello Hajam, my name is Muhammad Battan and this is my video response assignments regarding the subject and the chapter of Portland cement. I started out the first part of the Portland cement by getting a brief idea about Portland cement and its manufacturing. I learned that Portland cement is a binder material produced by the reduction of gypsum into fine particles, which is usually in grayish powders form due to its iron oxide composition. I also learned that when Portland cement is mixed with water, plastic bed can be formed and can also be named as a hydraulic binder due to its ability to harden and strength underwater. I went on to get a brief idea about the history of Portland cement when it was first introduced by the English bricklayer Joseph Epstein in 1824. I went on to understanding the manufacturing of Portland cement clinker, Portland cement, and Portland cement pozzolan. Portland cement clinker is produced is manufactured by two raw materials being the clay and the limestone under a temperature of 1400 Celsius in a kiln until it sinters. The decomposition of lime and clay occurs at a temperature of 900 Celsius and 650 Celsius respectively, while the impurities such as magnesia decomposes at a temperature of about 600 to 700 Celsius. After getting a brief idea about the manufacturing of Portland cement clinker, I went on to understand the manufacturing of Portland cement. Portland cement is manufactured by the Portland cement clinker plus 3 to 6% of gypsum rocks, and Portland cement is produced. After getting a brief idea about the manufacturing of Portland cement, I went on to understand and learn the four major oxide compositions of Portland cement, which are as follows: alumina, iron, lime, and silica. Alumina and silica are obtained by clay, while lime is naturally obtained and iron is obtained by the impurities of clay. Apart from the major oxides of Portland cement, there are some minor oxides such as magnesia, which are obtained from the impurities of raw materials when subjected to burning. While minor oxides can be very beneficial to the Portland cement, excess of amount of minor oxides can be very harmful. After getting a brief idea of the oxides of of Portland cements, I went on to understand the chemical compositions and learned the four main types, being the derivatives, being the C2S, C3S, C3A, and C4AF. After that, I learned their influence of compound composition upon characteristics of Portland cement and their different properties, being rate of reaction, heat of liberation, and contributions to strength, and how these properties are different in each chemical composition. Finally, I ended the first part of the Portland cement by unlearning the three different types of methods to determine the compound composition of Portland cement. The first one being the microscopy method, second one X-ray diffraction, and the third one computation by implementation of Box equation. The most famous one and the most used one is the computation, which usually needs the implementation of oxide of composition of the cement, and these oxides are implemented in the equation of Box and then converted into the and then are used to find the chemical or the compound composition of Portland cement. After finishing the first part of the Portland cement, I went on to the second part, which is the hydration of cement, which usually starts as soon as water and cement are mixed together. However, each compound can produce different types of products. I first went on to understand the compounds of and the hydration of C2S and C3S, which produces the S2H3 calcium calcium hydrate gels, which is usually a poor crystalline structure or nearly amorphous structure, a very high surface area, and a C2S ratio between 1.5 to 2. However, C2S and C3S can play a massive role in the ultimate strength of Portland cement. After finishing understanding the hydration of C2S and C3S, I went on to understand the composite and the hydration of C3A, which is usually rapid and can produces crystalline aluminum hydrates. However, rapid hydration of C3A causes immediate stiffening, and this can be named as quickset. Quickset can be prevented by adding gypsum rock into the C3A hydration to prevent quickset. However, too much gypsum can produce expansion and cracking. After getting a brief idea of the hydration of C3A and C2S, I went on to understand the hydration of C4AF, which is very similar to the hydration of C3A. Upon finishing learning the hydrations of the different the four main types of compounds of Portland cement, I went on to understand the types of waters in hydrated cement paste, being the capillary water, the absorbed water, and the interlayer water, as well as the chemically bound water. Upon finishing those types of water, I went on to understand and learn about heat of hydration, which is usually in exothermic reaction, and their different heats, and each compound and their different heats of hydration, uh, calcium to gram. Upon finishing the heat of hydration, I went on to learning setting. Setting is used to describe the stiffening of the cement base, and it can be also named as the stage from fluid into a rigid state. There are two main types or terms in the setting. The first one being the setting time, which is the length of time starting from the mixing of the cement and water until the cement paste sets is called. And also the initial set and the final set are used to describe the arbitrarily chosen states of settings. Also quick set as mentioned below. I also went on to understanding finances, which is the average size of the cement particles and is usually obtained by the apparatus named plane. These results are usually expressed in the terms of centimeters square per grams, and the minimum value of finances should be 2800 centimeters square. I finished my learning experience by understanding different types of tests that can be implemented in Portland cements, with the first one being standard consistency, second one being setting time, third one soundness, fourth one compressive strength, and the fifth one is finances. So this is my video response assignments regarding what I learned and understood from the first part and the second part of Portland cements, which occurred in the previous weeks of the course of material construction. So thank you, Huzam. I'm done.